Welcome to Section 2 of Chapter 20. In this section we look at the types of bonds. It begins with a gain or loss of electrons. Atoms lose or gain to meet a standard, a stable energy level, and as you learned in Section 1, stability is achieved in most elements when they reach 8 electrons in their outermost energy level. An atom that has lost or gained electrons is called an ion. An ion is a charged particle because it now has either more or fewer electrons than protons. The positive and negative charges are not balanced. It is the electric forces between oppositely charged particles, such as ions, that hold compounds together. Just like a magnet works, positive and negative ends. That attraction is what keeps the compounds together. Some of the most common compounds are made by the loss and gain of just one electron. An example, sodium chloride, commonly known as table salt, sodium fluoride, an anti-cavity ingredient in some toothpaste, and potassium iodide, an ingredient in iodized salt. These are all compounds formed by the loss and gain of just one electron. A neutral atom of potassium has one electron in its outer energy level. This is not a stable outer energy level. When potassium forms a compound with iodine, potassium loses one electron from its fourth level, and the third level becomes a complete outer level, just like in the example of sodium and chlorine to form sodium chloride. The potassium atom has become an ion. When a potassium atom loses an electron, the atom becomes positively charged because there is one electron less in the atom than there are protons in the nucleus. The 1 plus charge is shown as a superscript, written after the element symbol K plus to indicate its charge. The iodine atom in this reaction undergoes change as well. An iodine atom has 7 electrons in its outer energy level. During the reaction with potassium, the iodide atom gains an electron, leaving its outer energy level with 8 electrons. This atom is no longer neutral because it gained an extra negative particle. It now has a charge of 1 minus and is called an iodide ion, written as I minus. Notice that the resulting compound has a neutral charge because the positive and negative charges of the ions cancel each other. So once again, potassium gives up an electron in its outermost energy level to iodine, which has 7 electrons, and now it becomes stable. The compound potassium iodide is stable because the positive and negative charges are balanced. An ionic bond is the force of attraction between the opposite charges of the ions in an ionic compound. In an ionic bond, a transfer of electrons takes place. If an element loses electrons, one or more elements must gain an equal number of electrons to maintain the neutral charge of the compound. The formation of magnesium chloride, MgCl2, is another example of ionic bonding. When magnesium reacts with chlorine, a magnesium atom loses 2 electrons and becomes a positively charged ion, Mg2+. At the same time, 2 chlorine atoms gain 1 electron each and become negatively charged chloride ions, Cl-. and the graphic illustrates this process. Magnesium gives up two of its electrons to 2 parts of chlorine. One goes to, as in the graphic, the uppermost chlorine atom, and one goes to the bottom chlorine atom. Thus, Mg plus Cl forms the compound MgCl2. And you can see that the charges are also balanced. Cl minus, Mg2 plus, and Cl minus. 2 negatives, 2 positives achieves equilibrium or balance. The result of this bond is a neutral compound. The compound as a whole is neutral because the sum of the charges on the ions is 0. When atoms form an ionic compound, their electrons are shifted to the other atoms, but the overall number of protons and electrons of the combined atoms remains equal and unchanged. Therefore, the compound is neutral. Ionic bonds usually are formed by bonding between metals and nonmetals. An example of this, again, is sodium chloride. Sodium is a metal, bonds with chlorine, a poisonous gas, a nonmetal, to form the compound sodium chloride. Some atoms of nonmetals are unlikely to lose or gain electrons. They share electrons. For example, the elements in group 4 of the periodic table have 4 electrons in their outer levels. They would have to either gain or lose 4 electrons in order to have a stable outer level. The loss of this many electrons takes a great deal of energy. Therefore, these atoms become more chemically stable by sharing electrons rather than by losing or gaining electrons. We can illustrate this in the attached movie.
A sodium atom contains 11 electrons, 2 in the first energy level, 8 in the second, and 1 in the third. A chlorine atom has 17 electrons, with the outer level holding 7 electrons. When sodium and chlorine combine, the sodium atom loses 1 electron and the chlorine atom gains it. Thus, the chlorine ion formed is stable with 8 electrons in its outer level and has a negative charge. Sodium has lost the 1 electron that was in its third energy level. Thus, the sodium ion has a positive charge and is stable. Sometimes atoms combine by sharing electrons to form covalent bonds. Hydrogen gas exists in nature as diatomic molecules. 2 hydrogen atoms share electrons with each other. The electrons move around the nuclei of both atoms. When 2 hydrogens share electrons with oxygen, they form covalent bonds to produce a molecule of water. Each hydrogen atom shares 1 electron with the single oxygen atom.
The attraction that forms between atoms when they share electrons is known as a covalent bond. An example is in the graphic on the right. That is the molecule of water, H2O. A neutral particle that forms as a result of electrons sharing is called a molecule. The graphic is an example of a water molecule.